Hi everyone, I am Satish Chandra, an independent researcher, and I'll give you few information today on about myself. I'll start introducing myself and then probably we'll get started with the session. Again, good morning, good evening to each one of you, and thank you for Tenerife Summer Sessions team for having me. It's a real pleasure to be here, and my talk today is titled as Building Enterprise AI Agents with MCP and Production Governance. Over the next 30 minutes, I want to walk you through what's becoming one of the most important questions in the enterprise technology. How do we let AI agents actually do things inside our organizations? Take actions, touch real systems, move the real data without losing the control over what they do. We'll go one by one with each slide, and then probably you'll get to know what I'm speaking. A quick word about me. As I said, my name is Satish Chandra, and I'm an enterprise architect, and for the past 20 plus years I have spent most of my career designing in large scale systems like databases, different cloud platforms, and more recently on generative AI, and also autonomous agent systems for enterprise scale operations. Now, what I'm sharing you today isn't a theory, but it's drawn from a real production deployments where I have seen in different organizations, like building retrieval augmented knowledge assistants, autonomous operation agents, and document intelligence systems that run inside the large enterprises. Whether you take it's an airline industry or a finance industry or a retirement industry or a tech industry. So everything you will see is the grounded in what actually works and not just any like enterprise agent. And just as importantly, what breaks you when you get it wrong. So I'll go to the next slide to see how we will do that. With starting with a problem statement. The problem. What do you see as a problem? Why enterprise is hard, or why enterprise AI is hard? The challenges in enterprise AI adoption is something new that each one of the organizations are facing today. Let's start with the problem statements, because if we don't frame the problem clearly, none of the solution will land. So when the organization try to adopt AI agents, they run into three walls. So I would consider it as three walls. The first one is integration complexity. Every enterprise is a patchwork, dozens, sometimes hundreds of systems, each with its own APIs, its own authentication, its own data formats, and a fair amount of legacy that nobody wants to touch. Connecting an AI agent to all of that, one custom integration at a time, simply does not scale. So, what are the risks? The second wall is a big security risk. The moment you give an agent the ability to take actions, you have opened a door. Unauthorized actions, excessive permissions, sensitive data exposure, prompt injection, tool misuse, these aren't like hypothetical. They are the predictable failure modes of an agent that can act, but it isn't properly constrained. And lastly, the third one, governance gaps. The third wall is, as I mentioned, governance gaps. In a regulated enterprise, you can't have a black box making decisions. You need auditability. You need controlled execution. You need to satisfy compliance requirements. And in many cases, you need a human in loop for the high stakes calls. Here are the tension that ties all the three together. Organizations want innovation, but they cannot give up on control to get it. Everything I am about to describe in this session exists to resolve exactly that tension to enable innovation while maintaining the control. Let's go to the next slide and we'll start our foundations, how we evolve this enterprise solution skill. Okay, I'll start with what is MCP, Model Context Protocol. Everybody would have heard about that earlier in your life so many times when you're especially involved in a tech field. So let's see we'll go through a basic conversation of what is Model Context Protocol, and then we'll talk how it is the first piece of the solution. As its core, MCP is a standard. It gives us one consistent way to connect AI models to enterprise tools, services, and data sources. Instead of writing a custom integration for every single system, the trap most terms fall into, MCP provides a common interface. The agent can discover what tools are available, understand what they do, and interact with them consistently. Why does that matter so much? There are various reasons, and I pick like 3 major reasons. The first one, standardized integration, meaning you build a connector once and it's reusable. That dramatically reduces development effort across the whole portfolio, which is great. Second, better security, because tools access flows through a consistent layer. You can build your controls into that layer instead of reinventing them for every integration. And the third one, faster onboarding, where new enterprise applications becomes easier to add and easier to maintain because they all speak the same protocol. The way I would summarize it as, MCP is what turns isolated AI systems into connected enterprise assistants. It's the connection tissue, I would say, and this is the key point of whole talk. Connection alone is enough? No, it is not enough. A connected agent without governance is actually more dangerous than an isolated one. So MCP answers how do we connect. The rest of this talk answers how do we control, which is very important. Let's move on to the next slide. We'll talk about an AI agent architecture on an enterprise AI scale. Then we'll take into how the context and integrations, how the governance and monitoring, and how core AI reasoning are evaluated in this. Let me show you how this fits together architecturally. I think about an enterprise AI agent as 3 concentric layers. At the center is the core AI reasoning. Treat that this is a brain in a human body. It intercepts intent and makes decisions. Around it sits context and integration. This layer manages the agent's context and connects it through MCP to your enterprise systems. And wrapping the whole thing in governance and monitoring, this layer enforces policy, provides auditability, and gives you observability into what the agent is actually doing. Now, drawing governance on the outside is deliberate. Governance is not a feature you bolt on at the end. It is something like boundary, everything else operates the inside. That's what you are securing, like how a bank is secured, how the guardrails are set up around the AI infrastructure. Nothing the agent does reaches your real systems without passing through that outer layer. Security is a big concern. We have to follow every protocol that what we have got to secure our systems and enterprise systems. That separation of concerns is what makes secure, auditable automation possible at enterprise scale. So we'll go into the core competence of an enterprise AI agents in our next slide. If we zoom into the agent itself, 4 core components are doing the actual work, like reasoning engine, context manager, planner and tool selector, governance and audit logger. We'll go little bit into deep for each one. Like the reasoning engine interprets complex user intent. It weighs context, goals, and constraints, then selects the best path of action. The context manager preserves state across a conversation, retrieves the relevant enterprise knowledge, and makes sure the agent always has full situational awareness. It's not deciding in a vacuum. The planner and tool selector takes a high-level objective, breaks into executable subtasks, and routes each one of the right enterprise service through the MCP. This is where strategy meets precision. And at the end, the governance and auditor logger enforces your policy, guardrails in real time and captures a tampered evidence trail for every action where you want it to be secure. So everything the agent does is traceable and compliant by construction, not by after throughput. We'll go to the next slide and see how an end-to-end agent workflow designs. Now let's put these components in motion. Here is a workflow for a single request. The request is submitted, interpreted, objective, and identified the systems and then discovery tools. I'll put it in an elaborated way. It starts when a request is submitted. Let's say the agent interprets the objective. What is this person actually trying to accomplish? It then identifies the system needed to fulfill that objective and discovers the tools available through MCP to act on those systems. The important thing isn't it the 4 steps themselves, it's what they represent. This is controlled automation, not an unrestricted AI execution. Every step is traceable and every step is policy bound. The agent isn't in free running, but it's moving through a structured pipeline where each transaction can be inspected and governed. We'll go to the next slide and see how the governance is in depth. So the next one we are talking about governance by design. We spoke about end-to-end agent workflow. We spoke about how MCP is there, but the important piece here is how we are putting our governance in depth into the systems. This brings us to the core thesis, governance by design. What is that? Enterprise AI demands accountability at every single layer, and I want to be precise about the language here. A governance first approach is a foundational and not optional. It is not a compliance checkbox where you validate and move on. It is the thing that makes the whole system trustworthy enough to deploy. In practice, governance by design means 5 properties hold for every agent action. It must be authorized, explicitly permitted before it executes, and it must be explainable. The decision is transparent and human readable. It must be traceable. Every step is logged with full context. It must be auditable. The records are complete enough to support the compliance and review. And it must be policy compliant, where your organization rules are enforced automatically, not by hoping people follow them. If an agent action can't satisfy all the 5 listed above, in my view, it shouldn't run in production. We'll have to revisit each line item and then we'll have to fix it. We'll go to the next slide and see how permission manifest architecture is. So how do we actually enforce that? What is permission manifest architecture? We'll go that first because that's something deep we need to understand first. Instead of granting the unrestricted system access, permissions are defined through structured manifests. How do we actually enforce that? This is where the permission manifest comes in, and it's one of the most practical patterns I can give you today. The naive approach is to give your agent broad system access and trust it to behave. That's a mistake. Instead, we define permissions through structured manifests. Think a manifest as a contract that states exactly what this agent is allowed to do. Each manifest specifies the allowed tools and operations. It specifies which resources and which user roles are in scope. It defines the security scopes and the execution constraints, and it sets time restrictions and for approval requirements. The effect is that the agent operates inside a tightly drawn box. It can't reach for a tool it wasn't granted. It can't touch a resource outside its scope. You have minimized the security surface while still enabling the real automation. This is least privilege applied to AI. That is how you need to do your architecture with permission manifests. We'll see another scenario how role-based access control plays a pivot role. Permission manifests work hand in hand with role-based access control. The principle is simple but powerful. AI agents inherit your organization's existing security model. They operate within it, not around it. That's the main concept that we need to understand here. The agent doesn't get its own special set of God mode permissions. It's bounded by same role structure your people already live in. So an employee using the agent can query information, submit requests, and surface insights, but only within their defined data scope. A team lead can approve agent-driven workflows, delegate tasks, and access cross-team reporting, and an administrator can configure the MCP integrations, define the permission manifest, and push policy updates across the organizations. The payoff is that privilege escalation is prevented structurally by design. An agent acting on behalf of employee simply cannot do something that employee could not do themselves. That's an enormously reassuring property when you are putting this in front of a security team. We'll see one more of HITL decision making, which is human in the loop decisions, and how we will make that decisions. And this leads to the largest and last governance pattern. Human in the loop decision making. Here is the honest truth from my side. Not every decision should be fully autonomous. The goal isn't it to remove the humans. The goal is to put humans exactly where they add the most value and automate everything else. So we used a layered risk-based model. Low risk actions execute automatically, no friction. Medium risk actions request a confirmation, and a high risk action requires explicit human approval before anything happens. So what does that do? What goes in the high risk bucket? Infrastructure changes, financial transactions, security policy updates, and customer data modifications, access provisioning. These are few decisions that were the cost of being wrong is very, very high. So a human stays in the loop. This layered approach does two things at once. It improves safety, obviously, but it also improves the user confidence, and that second one is underrated. People trust a system far more than when they know the big calls still route through a human. So human in loop is something like very, very necessary in the decisions of what we are making in this generative AI world, especially in an enterprise architectures. We'll see how the security and observability is designed. Let's talk about the security controls that wraps all of this. I think About it is four buckets, which you are seeing it on the screen. Identity and authentication, verifying who the agent and the user are. Multi-factor, where it matters, and role-based authorization like RBAC policies along with that where it matters, and those to be on the top. Now, coming to data protection, secure API communication, encryption, and proper secret management to credentials aren't leaking through the agent. Input and output safety, validating what goes into the model, filtering what comes out, and protecting against prompt injection, which is one of the signature attacks that against agents. So how do you audit that? The audit logging, which has like full activity of records for both compliance and forensics. So that is something does go wrong, you can reconstruct exactly what happened from the auditing logs. So the principle underneath of all four is the one we keep returning to is security has to be woven through the entire AI life cycle. It is not something that you add afterwards. If you are retrofitting security onto an agent that already in production, then you are already behind. Now, having said that, we'll see how monitoring and observability will help the security and audits. Closely related is monitoring and observability. Once these agents are live, operational visibility in is what lets you improve continuously and critically catch failures before they affect the business rather than after. The metrics I care about majorly is how many requests are being processed and how tools are being used, response latency and failed operations, policy violations and approved requests. Those tell you whether your governance is actually firing or the security events alongside user satisfaction are bad. Because a system that's secure but that people hate isn't it a success either. Observability is what turns a deployment from one-time launch into a system you can actually operate and trust over time. We'll see where this pays off with some use cases, real enterprise use cases starting from next slide. So when does all this actually deliver a value? We spoke about observability, we spoke about policies, we spoke about security, we spoke about MCPs, we spoke about enterprise architectures and all. Now let's see where does all this actually deliver value. Let me give you my thought process in four domains where governed agents make a real difference. In IT operations, agent triage incidents autonomously, correlate logs across the systems, and escalate only when genuinely needs human judgment. The result is lower mean to time resolution and a lot less alert fatigue for your on-call engineers. In DevOps, agents accelerate release cycles, automating deployment validation, flagging configuration drift, and coordinating pipeline handoffs without someone having to babysit it. In customer service, agents resolve the common cases instantly, route the complex ones to the right team with full context, and surface the relevant knowledge all inside policy guardrails. So you have never trading service speed for a compliance risk. And in cybersecurity, agents monitor for threats continuously, validate compliance posture in real time, and generate audit-ready reports, compressing what used to be hours of analyst work into few seconds. We'll talk about how business process automation with AI agents helps in the next slide. Beyond those, these are a whole layer of business process automation. Agents streamline core workflows, enterprise knowledge management, and cloud resource optimizations. But I want to flag the caution on the side because it's the through line of an entire talk. As you increase autonomy, you introduce new challenges. Governance is precisely what lets these capabilities scale responsibly. The most powerful is the automation. The more than the governance layer earns its keep. Let's see what are the best practices and principles around this. Let me distill everything into 5 best practices you can take home. 1. Governance first. Design your governance and policy controls before you build the automation layer, not after. Second one, standardize the MCP. Use it for all enterprise integrations for consistency and security. 3. Least privilege access. Grant only the minimum permissions for each task actually requires, nothing more. 4. Keep humans involved all the times. Requires human approval for sensitive and high risk decisions. And 5. Monitor and audit, log every action and continuously reevaluate your security controls. If you remember nothing else from the practical part of this talk, remember these 5. That will help you to design a enterprise scaled agent. We'll talk something about architecture principles and that scale in the next slide. Underneath the best practices, there are 3 architecture principles that led to this scale as per my understanding. Separation of concerns. Keep reasoning, execution, governance and monitoring as distinct layers. When they are targeted or tangled together, you can't govern them independently because we don't know where the issue is happening. Test before the production, as always. Validate the agent's behavior in staging or in pre-production environments before it ever touches your actual enterprise production environment. And continuous evaluation. You have to reassess your security controls regularly because agent capabilities keep evolving and a control that was adequate 6 months ago may not be today. So you have to continuously evaluate and reassess the security controls as a best practice. We'll go to the next section and see what are our takeaways. Let me bring it together with key takeaways. Number 1, governance equals intelligence. Enterprise AI requires governance as much as it requires raw capability. A brilliant agent, you can't trust it's useless in production. Second, MCP simplifies integration. A single standard protocol cuts complexity across all your enterprise integrated systems. Third, controlled autonomy. Structured oversight is what builds organizational trust in these systems. And finally, the fourth, production readiness. Security, compliance, and observability are non-negotiable. Responsible AI architectures is what enables the enterprise scale transformation. And we'll see in the next slide the path forward to it. You begin with the foundation, then governance, then MCP setup, then RBAC policies. Then you run a pilot, deploy a focused use case, monitor it, iterate, and then you scale, expand your integrations, automate more, and keep auditing. Do not forget that. My practical advice, within my experience, begin with high value but low risk use cases. Measure outcomes against real business objectives, not vanity metrics. And expand your capabilities as trust gets established. Trust is earned incrementally, and the architecture I have described is what lets you earn it safely. And the last slide. Thank you very much for giving me this opportunity to speak. The single sentence I want you to walk away with this is, in the enterprise, the winners won't be teams with the most powerful agents. They will be teams with the most trustworthy ones. So governance is what turns capability into something you can actually deploy. Thank you so much for your time. I would be very glad to take any questions, and I'm happy to go into deeper for any of these patterns. You can also find me on LinkedIn, and you can send me a connection invite, or you can message me if you wanted to discuss more on this, or if you have any understanding or any other questions into this. Thank you again. Thanks.